welcome you all in 20th lecture of Electronics Measurement and Instrumentation. In this lecture, I will discuss the different type of energy meters. In previous lecture, I have discussed about the wattmeter. So, wattmeter is an instrument that measures the energy consumed in any circuit, the energy taken by any circuit, and it calculates the energy for it calculates average energy for the one cycle if we are measuring it by in the AC meter, AC circuit. So, that wattmeter measuring the energy consumed by the circuit for one cycle, but energy meter measures the energy consumed by the instrument or by any circuit for a certain period of time. So, when we measure energy for a time period, then energy meters are used, and we have seen at our house or at different companies or industries that there is always a placement of energy meter. So, if any utility company is providing electricity to any consumer, then the amount of energy consumed by that company or that consumer is basically measured by the energy meter, and then it is calculated in rupees by the tariff that is provided by the company itself. So, in this lecture I will discuss the electromechanical induction energy meter, whose construction basically energy meters are of different type. In previously we have seen that the electromechanical induction energy meter are there. Then there is advancement in meter, and now electronics meters are available at different places, and most modern cities, or we can say that where there is a multi-storied buildings are there, they are using smart card meters, smart meters. So, in this lecture I will discuss the electromechanical induction energy meter and the electronics energy meter. So, electromechanical induction meter we have previously in last lecture I have discussed about the induction wattmeter, and in this lecture I will discuss about the energy meter. So, the basic principle of both the meters are same, except few changes are there. So, energy meter is an instrument that measures the amount of electrical energy used by any consumer. So, utilities are basically the department which is supplying the energy to us, and the instrument, this energy meter is installed at the home, industry, organizations and commercial buildings where electricity consumption are there. So, in this the difference between the wattmeter and the energy meter is that the wattmeter in energy meter, here the energy is calculated by total power consumed over the time interval. So, that is power into time. So, here in wattmeter we are measuring power only, but when the power is integrated for a time period, then that is the function of the energy meter. So, energy meters unit is energy meters unit is watt second and watt hour, but generally when we are measuring the energy at any home or the industry, then we are measuring it in the kilowatt hours, because the consumption is in the range of kilowatt. Now, 1 kilowatt is defined as 1 kilowatt. Suppose we are placing a bulb of 1 kilowatt and it is blown by 1 hour duration, then it is said that 1 unit is consumed. So, 1 unit means 1 kilowatt hour. So, 1 kilowatt hour means 1 kilowatt of energy is consumed in 1 hour, that is defined as 1 unit, and different utility companies are charging according to the unit consumed by the customers. So, types of energy meter, there are 3 types of energy meter. The first is electromechanical induction energy meter. The second classification is that electronics energy meter, and third is a smart energy meter. So, in this lecture I will cover only the electromechanical induction meter and the electronics energy meter. In next lecture I will cover the smart energy meters. So, electromechanical induction energy meter. We can see in the figure that this meter is similar to the wattmeter that I have discussed in last lecture, only there are two difference. In wattmeter we are using indicator, that means a needle is used to display the wattage consumed by the circuit. But here in place of needle, because here we do not need a needle, we do not need to read instantaneous value of the energy consumed, but here we want to evaluate the energy for a time period. So, for this purpose we are using a recording device, that is known as registering system. So, there was a needle, here it is a registering system, or we can say a recording system. Similarly, there is, since there is movement of needle is there, so we are using a control spring to control the motion of needle. So, that needle can deflection of needle should be proportional to the energy consumed in one cycle, average of the energy consumed in one cycle. So, here we are using braking system. So, braking system is used, this is a permanent magnet and this is disc. So, when disc is moving, disc is producing an eddy current and that eddy current is cut by the braking magnet, and then the when there is no consumption of energy, or the when both the torque, that is the torque due to the braking magnet and the torque that is produced due to the current, when both are balanced, then it will stop the movement of the this disc. So, here we can see in this diagram that there is a pressure coil. So, pressure coil is basically this pressure coil, or we can say that is voltage coil. So, this is a shunt magnet and pressure coil is wound on the shunt magnet. This is a pressure coil and it is connected in parallel to the load. We can see that it is in parallel to the, this is load and it is in parallel to the load. So, it is in parallel to the load, it means the current that is flowing through the pressure meter is proportional to the load voltage, because it is basically measuring the voltage of the load. So, this current which is flowing through the pressure coil is proportional to the voltage, load voltage. Then there is one more coil, that is this coil, this is the current coil. We can see that it is connected in series with the load. So, the current coil current is proportional to the load current, means whatever the load current is drawn by the load circuit, that is flowing through the current coil. There is a disc, when the current is flowing in pressure coil and the current coil, then because of interaction of these two currents, because of the flux generated by these two current, the interference of these, or the when these two flux connect each other, then this disc will move, and this disc move because of the flux generated by the pressure coil and the current coil, and this the movement of disc basically shows the value of the energy consumed. So, in this type of meter, when it is placed at a home, we can see there is a red mark there, and when it rotates one cycle, then we say that yes, it consumed 1 unit of energy. So, this disc is basically moving because of the interference of the flux of these two magnets. Then there is a brake magnet and it is pivoted on a and this braking magnet basically used because of this, when this disc move and the flux which interact, the flux that is produced by the pressure coil and current coil. So, when they interact with each other interface, then that will generate a eddy current in the disc, and so because of that eddy current and this permanent magnet, when they interference, then this disc will this braking is produced. So, in center limb we have seen that the pressure coil is placed, and apart from the pressure coil there are 3 or 4 copper bands are there. So, the copper bands main function is to align the flux produced by the shunt magnet in such a way that it is exactly perpendicular to the supply voltage. it means the current that is flowing, the flux which is produced in the shunt magnet, produced by the shunt magnet is exactly perpendicular to the supply voltage, and we can adjust, we can align these flux by just moving the copper band. Then moving system has aluminum disc and it has very high resistive aluminum disc, and which is mounted on the shaft of alloy and placed in the air gap between two electromagnets. So, the eddy current is induced in the disc and cut the magnetic flux that are produced by the pressure coil and by the current coil. So, it cuts the magnetic flux, and the interaction of flux and disc induce the deflecting torque. So, the number of rotation of disc is basically a counting of the total energy. Then the braking system I have already discussed. This is the aluminum disc induce the eddy current when rotate, and this eddy current cuts the magnetic flux of the permanent magnet, and then it produces a braking torque. Now, the main the important unit of this is, that is the registration or the counting mechanism, or we can say the recording mechanism, because we can see in energy meter they record, the energy meter records the total energy consumed till time, and it also record the maximum energy consumed at any time, and so many quantities are recorded in the meter. So, registration is very important part. So, basically it records the number of rotation of aluminum disc. As we know, the rotation is proportional to the energy consumed by the load in kilowatt hours. So, there are three type of registration units: the pointer type, cyclometer type and the solid state type. So, we can see here in the pointer type that first of all, when this pointer moves complete one cycle, then when it completes one cycle, then this meter will complete this indicator will go from 0 to 1. So, when it complete 10 cycle, then it will complete one cycle, and when it completes 10 cycle, then it will complete one cycle. So, this is the meter indication meter. Similarly, in some energy meter we have seen such type of indicating device, that it indicates the energy consumed in the form of digital form, in the form of 0, 1, 2 till 9. And then there are solid state meters, indicator meters are also there, that indicate basically a 7 segment display. So, this type of meter is also available. Now, the torque equation that is developed by the interaction of the fluxes. So, here we can see that this is a shunt coil and this is the series coil and the moving disc. So, V is suppose the applied voltage and IL is the load current, Z is the impedance of eddy current path, phi p is the pressure coil flux generated, and phi s is the current coil flux value. IP and ISC, IP is the current corresponding eddy current value of shunt magnet, and this is the corresponding value of the series coil. Similarly, this eddy current EMF produced, EP is for the pressure coil and this is for the series coil. Phi is the phase angle bit of load, that is the phase difference between the load voltage and current. So, we can see the total torque deflection, that is TD is equal to K, that is the proportionality constant, and that is phi p Is cos phi minus phi s IP cos 180 minus phi. So, this is the phasor diagram of energy meter. Here VPH is the load voltage, voltage across the load, or we can say the voltage of the shunt coil. So, it is the voltage of voltage across the load. This is the current flowing through load, and there is a phase difference of phi angle here. The phi p is in phase with Is, the current that is flowing in shunt coil. Similarly, the series coil is in phase with the series voltage, and here the VHP and IP are 180 degree out of phase. So, here we can see the torque is proportional to phi p is. Is is now the current in series coil and phi p is the flux generated by the parallel coil. So, these the current in the series coil and the flux in the parallel coil they will interfere each other, and here we can see there is a angle difference between both are phi. So, this is phi p and this is is and there is angle difference of phi. So, it is phi p is cos phi minus phi se ip phi se and ip. So, ip is in phase with this IL current. So, here it is cos 180 minus phi. So, when we simplify it, cos 180 minus theta is equal to minus cos theta, and so it will be when we take cos phi as a common, then cos phi phi p IAC plus cos SE IP is there. Now, we know that the current that is flowing through the parallel coil, that is the parallel coil. So, that IP is proportional to the current that is flowing in the shunt coil is proportional to the load voltage. So, it is proportional to the load voltage and it is also proportional to the flux generated by the parallel coil. Similarly, the series current is proportional to the load current because it is connected in series with the load, and it is also proportional to the flux produced by the series current. So, here when we put these values, then it is phi p ISC is proportional to V H P IL and it is proportional to A V P H IL. Similarly, this ISC IP is proportional to load voltage into load current, and this B is the proportionality constant. So, this T is proportional to A into VHP IL plus B VHP IL cos phi. So, A and B is taken as constant. So, T is proportional to the load voltage into load current into phase difference between these two. Here A and B are constant. So, finally, the torque produced to move this disc is equivalent to K1 VHP, that is load voltage, load current into phi p. Now, this load is balanced, this movement of the disc is now balanced by the torque produced by the braking magnet. So, suppose the braking magnet is producing a torque of Tb. So, Tb will be proportional to the speed of the disc. So, Tb is proportional to the n, and Tb is another constant we have taken K2 into n. So, now T is equal to K1 VHPL VPHIL cos phi. So, this is the torque that is produced by the disc, and this is the torque that produced by the braking magnet. So, the steady state achieved when both the torques are equal. So, when Tb is equivalent to T, at that time the disc will stop. So, Tb is equal to this K2 n is equal to K1 VPHIL cos phi. So, finally, the number of turns is equivalent to K1 by K2, then load voltage, load current into phase difference between these two. This is the rotation produced by the disc. Now, the energy meter's function is to calculate the total energy consumed for a time period. So, that total energy consumed is now the energy consumed by this and sum of all the energy consumed. So, we will take the integration of that. So, total number of revolution is equal to integration of n into dt. So, it is K1 by K2 VPH load voltage, load current into cos phi dt. So, it is the constant K and then true power into dt. So, it means the total number of revolution made by moving disc is a direct measurement of the energy consumed by the load circuit. So, this way we can calculate the torque produced by the torque produced by the fluxes generated by the shunt and series magnet, and we can also calculate the total number of revolution, means the total energy consumed till time. So, now features of induction energy meter. So, it is most commonly used energy meter, and it has lower friction and high torque to weight ratio, because disc is very light weighted, and they are inexpensive, reasonably accurate, and can retain very accuracy over considerable range of load and temperature. There are different errors produced in the induction meter, induction type energy meter. The first error is that is produced in the driving system. So, driving system means there is a phase difference of lack of symmetry in magnetic field. So, because of that the energy is the error is produced. Similarly, in braking system, because of a change in disc resistance, and there are some friction always generated when there is a moving part. So, because of these two there are error due to the braking system. Similarly, in registering system also mechanical parts, since it involves mechanical parts, though so calibration is to be done, otherwise due to friction, overloading and phase angle variation due to temperature effect, creeping of the meter, etc. So, error is produced in the registering system also. Now, advantage of induction meter, it has no moving iron part, high torque to weight ratio, and it has good damping is there, and less effect on the stray magnetic field. And what is the disadvantage, that it can only measure AC current, AC measurement energy in AC only it can measure, it can't measure the DC, and it has a non-linear scale. Now, in 3-phase energy meter, this is similar to the single phase energy meter, and we have already seen in last lecture ki if there are 3 wires, if there are n number of wires, so we can measure the energy or the power by using n minus 1 elements. So, here we can use 2 energy meters to measure 3 phase energy. So, here we can see that the 2 meters are there, and the 2 meters are connected separately. They are separate series coil, shunt coil, and the disc, and the magnet is also different. So, in this way we can measure the single phase 3-phase supply, energy consumed in the 3-phase supply. Now, what is the problem of conventional energy meter? That since there is a moving disc, there is a magnet produced, so it will consume some power. Then because of the wrong because of this the wrong billing may be done. Electronics energy meters are more accurate meter, and there is no friction generated, and there is no magnetic leakage there, because the electronics equipments are used, electronics devices are used, and then tampering is also slightly not possible in this meter. So, electronics energy meter is of 2 type, one is analog electronics energy meter, and second is digital energy meter. The basic difference between this analog and digital meter is that in digital meter there are sensors, and sensors sense the voltage and current, and then they will produce the voltage. In analog energy meter we can see in the figure that the voltage, this is the voltage, the parallel, the current coil, in place of shunt magnet, here we are using a current transformer. So, through this current transformer the current is fed, which is proportional to the load voltage, and here this voltage divider, through this voltage divider the line current is fed, and there is an digital to frequency converter. Basically it converts the value into pulse form. So, that pulses are counted by the counter, and then it shows the total energy consumed. Here this is a multiplexer circuit. So, it will select once between the voltage and current, and then it will fed to the digital to frequency converter, and then it converts it into pulses form, and that is registered by the counted by the counter, and it is displayed by the 7 segment display unit. Similarly, in digital energy meter there are current sensor and voltage sensor. So, voltage sensor sense the voltage and current sensor sense the current, and these are fed to the high level processor, and these high level processor also calculate the phase angle between these two, and finally, it is also converted into pulse form and the counting is done, and then it is stored in the memory for the next whenever we want to use the measured power, we can use it. Thank you for all.